Hello everyone, and welcome into another live stream. Hi the Siphon, hi the Object Animator, hi the Deep Guy, hi the Happy. Welcome. Welcome everyone. How are you all doing on this fine day, evening, morning? It's right now just past midnight for me, which means I'm starting the live stream. Oops, let's play all of the music. Oh, almost spilled my water. That would be unfortunate. Would have been certainly. There we go. Being forced to be in a Zoom lecture? Oh no! What's it about? Just finished my homework. That's good! I'm glad you finished the homework before joining in on stream. I'm wasting money about the Panda Bear plushie. Good for you, what do you mean wasting? If you don't spend money, actually, you know, saving up money is wasting money. Like, money is meant to be spent. If you're not spending it, you are wasting it. Anyhow, your stream went live as soon as I finished. I know, I was waiting. I was waiting for you to finish your homework. To only then start the live stream. Anyhow, how's everyone doing? How is everyone doing today? I finished rendering everything for the chemistry video when it comes to why atoms bond. That's kind of it for me. Hi the Stomp! Oh, it's for you, it's gonna be 2 streams in one day, isn't it? For most people actually it's gonna be 2 streams in one day. To be fair, I'm just switching from late live streams to early live streams. Can't sleep, so I thought might as well. Remember number theory script I did last time I was on stream? I do remember. Make gambling C++. Oh, good for you! I feel like a flower smell next to a bee trying to extract its nectar. That's an oddly specific feeling. There. All the animations. Here was the last one about why noble gases. Oh, actually no, there's one more. I think I might have been mistaken. Well, statistical chemistry is gonna be a segment. So that's just a gas, and we call them noble gases. So right here, actually, this will be the last, the very last. Sent this. Hydroatomic! Oh, hell yeah, another $5 chart. Hold on, let me add it to the list. Let me add it to the list of donations. Also, Atomic, you're a Patreon. You can, because today technically we're having a MAKiT making stream, which means you get to pick what the next MAKiT should look like. How about that, huh? What MAKiT should I make? What day is it today? It's 31. Atomic steel, $5. Neat, yeah. On part 6 of it now, it's 3 pages long, that's good. Noble gases. Is gases spelled with 2 S's or 3 or 1? No, 2 or 3. Gases. It's 2, correct? And we still leave as 1. Okay, yeah. Never mind, there's alternative, it's either one. whatever. I'm spelling mine with 2 because I feel like it. It's Halloween today. It should be so Halloween. Oh, it is Halloween, right? I don't celebrate stuff. I forgot it was Halloween. Wow, what a coincidence! Am I right? Just make a live stream on Halloween. That's incredible. We could do the evil MAKiT, but I already have the evil MAKiT. Wouldn't be much of a MAKiT making live stream, more like MAKiT repurposing live stream, or we just set up the evil MAKiT. I mean, friendly MAKiT. That's the name. I'm back in hour. Alright, Siphon, bye. Have a good one. No, Lucas, what color should I pick? No, it's awful. It's garbage. White. White. Classic white. Can't go wrong with white. Oh, electrons. That's a good one. It's not the fact it's a bit too bright. Fortunately, I'm pretty certain we haven't really used it anywhere, which means I can set it to 1. Nah, that sucks. Never mind. White. No, white also sucks. Why does the white suck so much? My goodness. Just look good. Oh, I know why you suck so much. Whoops. What's this? Principle 1. Okay. Principle 1. And then just... Okay, that's already much better. Make it the MAKiT in the memes channel. The MAKiT in the memes channel. Oh no, did you send something? Wait, making. You mean the toys? How am I supposed to make that? That's just a toy. You care to elaborate, or do you want me to just take creative control? Also, MAKiT totally looks like a witch. Try again, a wizard. I don't practice witchcraft, I practice wizardry. There's a difference, it's important. This sucks, I don't like it completely white. No, this also sucks. This... I don't hate it, but I don't love it. I kind of don't care for it, to be honest. Let's do 50, and let's write here object convert to mesh, and then let's do this p selection, and then actually 60 right here. Noble gases. Sweet. Brenda. Doing research. Flame I might be doing, because I haven't found the answer to the question last stream. Hi there, Flame. Welcome to this totally next day live stream. It's technically next day, and I'm counting it. It's my live stream I get to. Live on 5 in the morning. Yes. I can't sleep. Hi there, Eggs, by the way. Welcome. I still have the question, and I can't seem to find a solid, like, I have a theory, but I can't seem to find a solid source to back me up. And I'm going mad with this. It's the Hech molecule. Because helium, hydride, was it? Helium hydride, if I'm not mistaken. That molecule, that's an ion. That's an ion. And I get it, it's like an acid ion IC. However, what about the non-ion one? Is it theoretically possible to make a non-ion helium hydride? A neutral helium hydride? No, there's like a neutral molecule right here, right? And then is not stable in the ground state. Does it being not stable mean that it's not a viable molecule, or is that it will quickly disappear when it interacts with anything?
Hello?
Hydroflame. Oh, flame. Thank
Hello.
goodness you joined in. I did just precisely ask my question. My question is about the helium hydride because... Okay, hold on. Let me first reach out and then I'll explain exactly what my theory here is. Blender graphics. Yes, Blender graphics. I'm making a video. I'm doing streams for 635 days now. Yes, 635 days and counting. I really need a hobby. No stream schedule. Listen, I'm killing two birds with one stone. I'm streaming because I can't sleep. And I suppose that's it for now. So here's my theory. Right? Here's the thing. If I'm not mistaken, hold on, you're a bit quiet. I don't know if that's my fault or... Let me just... Yeah, it was my fault.
Oh wait, I can fix that.
No, don't worry, it's fine already. It's fine now.
Is this better?
Yeah, it's alright. It was my fault. So, my theory is, like, when you have a it's gonna be a simplified version. Two hydrogens, right? Then when they bond together, they each have an electron. They both fall into the sigma bonding. So you gain energy, whatever. When it comes to two heliums, however, obviously then they jump up to the anti-bonding orbital. So my theory is, when it comes to bond between a hydrogen atom and a helium atom...
You're saying they will still have a bond, like a...
Yeah, then...
They'll only have one...
Yeah, then this is a 2 times E gain and a delta E loss, so it's still a net delta E gain. However, at the same time, 2H plus... wait, no, H2, I'm an idiot. H2 plus 2HE should be better than 2He. And so my theory is this is why helium hydride doesn't actually exist. But if this truly is the reason why it doesn't exist, then it could exist in theory if your entire universe was just a single hydrogen atom and a single helium atom. However, I haven't been able to find a single source backing me up on this. Everyone is just talking about the ion because obviously it's way more interesting.
Yeah.
Like this is the Wikipedia.
It's probably because the ion is the only one that's actually existed.
Yeah,
the other one hasn't. There's no.
That's a fair reason. However, this is the Wikipedia page about the ion, and then the neutral one just has like this. That's all it says about the neutral one, and then all of these are, well, kind of unrelated. There's one paper here, I think it was this one, where it like, it sometimes referred to it as helium hydride, but then in all the spots it just added a plus. So sometimes it's a helium hydride, sometimes it's an excited helium hydride, and sometimes it's helium hydride ion. And I have no idea if this is just them not adding a plus for the sake of simplicity, or
when they write it in text, they're not including the plus.
Yeah, and it confused me so much. I was reading through it, I was so excited, but then it turns out they just refer to it right here as helium hydride, but then helium hydrogen ion. And I mean, that's like the best paper I have found about helium hydride. What's your expert take on this?
I mean, in general, it's like there's no reason for helium to want to bond to anything, and for hydrogen to prefer being with helium than being with another hydrogen.
However, hypothetically, if the entire universe was just a hydrogen atom and a helium atom, would it work?
I don't know. I don't know if the energy would actually be lower from just one electron in the sigma bonding orbital.
I see. So okay, when it comes to, I'm assuming when it comes to bonding, there are other things at play, obviously. So delta E. So what you're basically saying is that the gain of delta E isn't enough because then you need some, you need also a certain amount of energy. So delta E not only has to be greater than 0, it has to be greater than something. And in this case, it wouldn't be greater than X. Is that, am I understanding correctly, or?
I mean, yeah, because if you imagine there's like a transition state somewhere, like it needs to have an incentive to go one way rather than the other when it's at the transition state, right?
Okay, but hypothetically, if I had an unlimited amount of energy and I just kept retrying the reaction, like eventually it could end up being a hydrogen hydro. I really want to make it work. Because for the video it would be an absolute banger of an example as a theoretical molecule, and also it would both be a banger example of a theoretical molecule which normally people would think is impossible, and at the same time explaining exactly why it's only theoretical and wouldn't practical. But apparently no one cares about theoretical molecules anymore, and everyone just cares only about those that can actually exist.
There's probably an obvious reason it doesn't work, and I just can't see that reason because I'm not an expert. But one of the things with
if you're not,
so you know the molecular orbital diagram.
Yep.
Where you draw the two things on either side, and then you draw the bonding and anti-bonding. With those, if you have two different nuclei, then your starting orbitals are not the same energy. So your starting hydrogen and helium orbitals, your 1s orbitals, they're not at the same energy.
Yes.
And that then influences the positioning of the bonding and anti-bonding
didn't
orbitals.
think of that for some weird reason.
And so that's what I'm thinking is probably at play somewhere.
It's so annoying though, because I really can't find a single like good source right here to explain this. But to be fair, it's a weird question. I get it. I really originally I just thought it would be like a cool fun fact to add in the video, but then it's haunting me at this point. Hi the Fuji. The other person is Flame. Flame is my chemistry expert. It's when I have a chemistry question, better call Flame.
And then I still can't answer it.
To be fair, it's better than what I had. It's still a better answer. And at the same time, I am asking you about, like, it is a wild question to ask.
Yeah, it's...
I have no input on this. I am not well versed enough of this. Don't worry, object animator. This is... this is bizarre.
The helium just doesn't bond with anything. Like, it just doesn't do that, you know?
I mean, I know. I'm just saying theoretically, or hypothetically, it could. I'm not saying that it exists.
There's just no incentive for it.
But like, there is no incentive for it to not bond too. So that's my argument.
Well, there is something at play that means that if you make it bond with something else, it's at higher energy than if it were just by itself.
Yeah, I mean
that is why it's not doing anything.
I just realized this paper is from 1985. Oof, that's fun. I mean, I'm assuming, yeah, obviously, I'm assuming there has to be something. But here's my question, though. Because what I'm trying to figure out is if it truly is higher in energy when it's bonded. So, do you know that for a fact that it's higher energy when it's bonded?
No.
Yeah, so what I'm trying to figure out is if it is actually higher in energy when it's bonded, or if it's nearly the same in energy, but the difference is so slight that, you know, it's just gonna react with practically anything. So, you know, so, because to be fair, what we're talking about here is a single helium atom, which is fine enough, but a single hydrogen atom, that's pretty rare. That's like practically doesn't exist kind of rare.
Yeah, it's not something we ever use.
Yeah, so like considering the energy of hydrogen, then hydrogen, then helium hydride would probably have around the same amount of energy. So it will still be incredibly high. And so in the universe. So yeah, so obviously, as I mentioned, my theory is two hydrogens, the hydrogen gas and two heliums, have much lower energy, and so much easier for them. And so, why would helium ever bond with hydrogen if hydrogens can just bond with themselves? It's pretty unlikely you have a single atom of just a single proton of an electron.
that part's the obvious part. Yeah.
Yeah, but then still the question remains, theoretically, if we could
You're saying
isolate
that
a
in
single.
theory, if you had a universe where you had a helium and a hydrogen atom,
Yes.
and you shove them together,
Then would they
what
bond?
would stop them from?
Yeah, what would stop them exactly? Because, well, they should have lower energy. I mean, it's not they should have lower energy. I haven't been able to find a reason why they wouldn't have lower energy. Therefore, they would bond QED. That's how science works. It's not up to me to prove my claim. It's up to you to disprove it.
I don't think that's how it works.
Why does it make it feel like a conspiracy theory is trying to make a point right now? I'm just saying, oh, is this going to be another one of my hills?
It's a very weird question.
It is really weird.
And it's like,
Because
it's a completely hypothetical
It's
question.
purely hypothetical. I've never heard a more hypothetical question in chemistry. I don't even know if you could. This is like would it be possible to have hydrogen gas with unbonded hydrogen, kind of? Or rather, if you had positive hydrogen ions, would they exist just as lone protons, kind of question? Like, this is on this level. Unless you can have just positive hydrogen ions, and I'm just not aware of something with plasma or whatever witchcraft you chemists do. Fire lightning at it or something. Also, oh yeah, that's another thing, completely unrelated, but recently I thought about it, because when you have a lightning, right?
Mm-hmm.
It's ionizing the air, if I'm not mistaken.
Yes. Yeah.
So what does ionizing mean exactly?
It means
You can just simplify it or use extremely complex words, whatever is more convenient. It's
ionizing means turning something into ions.
yes. So when it comes to
So that can be giving electrons or stripping electrons away.
okay, so when you have a lightning and it hits O2, then it turns it into plus lightning. I'm a chemist, trust me. Lightning plus O2 will give us like O2 plus or O2 minus, for example. I just want to. It is just my genuine, sincere opinion that ionizing the air and lightning is just unfiring the air, and I feel like completely unrelated, but it is something that I want to state publicly, and just remind me of it. I feel like it should be considered unfiring the air.
In what way?
Well, in a way, how when you use air to oxidize stuff, right? Then you basically burning it. You're turning it from an oxidizer into something that can't oxidize stuff. Well, I guess in this case it depends if it's a positive ion, negative ion.
Okay, no, when you oxidize something,
Yep.
You take electrons from it.
Yeah. So hold on, because the naming for this is awful. So I need to.
When you oxidize
I always remember it because it's reduction.
Away.
I always remember this. Okay, not gonna lie, I know you did just literally tell me all this, but I'm still struggling with
the way to remember it is
the way I remember it is that the reduction doesn't reduce the amount of electrons because it reduces the charge. Did I go backwards or?
Let me.
I am so glad that electron being negative is the standard. I feel like it would be way too easy.
This is all you remember. You remember oil rig, and that is the way to remember.
Reduction is gain is certainly a chemistry moment. The idea to set electron to be negative and then have a reduction, which means reduction of electrons. No, reduction, which is reduction of charge. So basically a negative of a negative. Yeah, so okay.
It's because you're reducing the oxidation state.
Okay, so oxidation is loss of electrons, which means if you have a positive oxygen gas ion, then that would be unburning the air. And that's a claim I'm willing to. That's once again.
Well, no, because when you burn something, you oxidize it.
Yes.
So it loses electrons. Which means
Oh yeah, so negative oxygen ion then. No wait, am I thinking? No.
See,
the
thing is,
oh, because
giving something electrons isn't. I don't know if that's really reducing it, because it's this thing called oxidation state.
We're studying redox, no cinnamon toast. We're just trying to make it is just trying to be funny in a make it is trying to be funny in a scientific way. It's not working out well.
Because the thing is, oxidation state is only like within a compound. It's not. When you just add or remove electrons from something, you're ionizing it. That's there, and oxidation state and oxidation and reduction are different things to ionization.
I see. Never mind then. I thought I was clever.
I mean, you are clever for linking the two, because
Well, don't God give me that pity. Come on.
No, because the thing with you is you ask really interesting questions that don't come up ever because
yeah, I mean,
reasons, and so they're good for me for like challenging what I understand.
I mean, the thing is, I am genuinely upset about the helium hydride. I understand completely why no one cares about this, because like, why would you? There is absolutely no. How could there ever be a practical application?
It's the same as like talking about helium fluoride. You know, like
yeah. At this point, you would basically need to. Well, the only way to make helium hydride, neutral helium hydride, would be to do it with like individual atoms. There is, it's basically at this point it's kind of like separating quarks apart. The amount of energy you would need is insane. We're trying to unburn air. Well, I really want to unburn air.
yeah, when lightning strikes, you create plasma, and plasma is, I think, a collection of ions. Well, my instrument uses I think it uses like a stream of plasma, and it passes the sample through it, and basically ionizes the sample as it goes through, turning it into plasma, and then that travels through the instrument because it needs to be an ion.
Yeah, in order for the electromagnetic coils, whatever, the electromagnetic coils, same thing. In order for them to push it forward into the basically the chemical equivalent of an eye.
Yeah, because it measures two things. It measures the mass, and it also does this whole like excited state dynamics. With
yeah, it also measures velocity at a point, like, you know, normal physics.
I think what it does is the laser makes it kind of fall apart, and the way it falls apart gives off kinetic energy. Well, as it falls apart, the bits that come off all have kinetic energy, and this thing can see where these bits have gone and the kinetic energy they had, and then that tells you how it fell apart. Therefore, the excited state dynamics of that molecule when the laser hits it.
First of all, happy birthday, Art Fox. Happy birthday. Good for you. And when it comes to actually the way it's measuring velocity, that's not at all how I thought it was measuring it, actually. And now that you mention it, that's a lot more obvious way to do it. And I was imagining it in a completely different way.
Yeah, I think I described it wrong the first time, to be honest.
No, it's not really. No, in this case, this is just my bias. I genuinely it's kind of wild that I genuinely thought it was like something with relativity, where it used like, you know, the fact that light always travels at the speed of light as a constant, like the shifting of the light spectrum. Yeah,
I get what you mean.
Yeah, in retrospect, it's not a clever way to do it, actually. What you said, it makes a lot more sense, actually. Still, it's really cool.
I mean, yeah, it uses a couple electrodes to yeet something up towards this detector after the lasers hit it. So
Yeah, so it's not really measuring like speed at the point, but still, it's really cool. Because it's measuring the effect of speed. Still,
it's annoying because when you search up the method, you don't get any like clear stuff. There's no Wikipedia page, which I think is insane.
oh, that is wild. Actually, that's it. That's how you know you've reached, the expert level
Oh,
where
this might be.
if
this
you're
might be a
working
wiki
on
page.
something that doesn't even have a Wikipedia page, that's how you know you're in deep. Hi, Ninja. Can light travel slower than the speed of light? No, it cannot actually, but I wouldn't say it sounds really stupid. I wouldn't say so. No, it cannot travel slower than the speed.
Okay,
Unless
it's
I'm
part
wrong.
of a Wikipedia page.
Unless I'm wrong, light cannot travel slower than the speed of light. However, when it's stuck in something, where it normally would travel lower than the speed of light, then you have to remember you have molecules, and then when light basically enters an object, it's just bouncing around these molecules, and that's what's slowing it down. As far as I'm aware, it cannot actually travel slower than the speed of light, but maybe there is some relativity shady business. Improvements to product imaging technique. Oh, once again, there's just a single. I see. Custom imaging. Resolution. For example, volume interaction of the molecular beam for the ionization laser is say 1 meter by 1 meter by. Wait, why is the laser measured as a volume? Then
I don't know.
Oh, I see. The emission is quite larger than the limit of the channel.
This is some hardcore physics, which I do need to understand at some point, but I don't understand it yet.
Without some further improvement, the velocity resolution would be limited to about 1 part in 25 minutes. This does sound wild. Hi there, Ali, by the way. It's going well. I can't sleep. It happens. I was thinking light travels to water. Yes, then it's actually funny enough, even though light traveling through water is traveling on average lower at the speed lower than the speed of light, it is still traveling at the speed of light. Physics is simple and not confusing.
It's just because in different mediums the speed of light is different, but it's always traveling at the speed of light in that medium.
Yeah, so basically it's traveling slower at the speed of light. It's traveling slower than the speed of light at the speed of light. It's simple. No, I am actually curious. Hydrogen hydride. The only problem is it's always gonna be not hydrogen. No, hydrogen hydride is gonna be pretty obvious. Helium. The only problem is that it's going to show up just the ions. I don't care about the ions. I don't care about the plus. I don't want the plus. The oldest type of molecule, not what I'm looking for at all. Is there like a keyword to lower the priority on ions or something? That would be convenient.
There's a way to exclude search results in Google.
Hold on.
I think if you put
but if I exclude
dash,
ion, but if there is some sort of paper or some article written about helium hydride, it will probably also mention the ion. That's my problem.
But you could still see which ones don't mention the ion.
I don't know if there will be a single article.
I just think the odds are higher that you find it through ones that don't mention the ion than if you look for ones that do.
It's something about phase, right? Phase with what? Phase? You mean light traveling at the speed of light? I mean, there probably is some relativity business where light can travel at speeds slower than the speed of light, but I don't want to get into the relativity business. When you remind me, time to take my sleepy meds. I have to take them 2 hours because I want to fall asleep. No, that's neat. 2 hours. That's precisely how. When I'm probably gonna fall asleep, maybe, or maybe 4. Cricket script that searches the papers. Let's make it happen. Oh, we could do. To be fair, but how would I? Oh no, that's not an easy script. I would basically need to. look up helium hydride. That's not followed by an ion. Follow helium hydride ion. I don't care about ion. I care about neutral helium hydride. Just a normal sane person looking up a normal sane molecule. This is actually astrochemistry again.
Yeah, because there's no way this thing is ever going to exist on Earth.
I don't know.
If it exists
like
naturally, it will be in space.
It is such a wild molecule, too, because it's basically helium with a proton. That's what it is. It's insane to just have a. It makes sense, to be fair, that if you have noble gas as noble as helium, I would argue helium is the noblest of noble gases, then it makes sense that the only thing it could ever bond to would be a proton. Because there is nothing else it could just attach this easily to.
Yeah.
And also it makes sense that it's a strong acid. It's actually a comically strong acid.
But it's basically just...
It's like a crossbow. It's like
H+.
Yeah, it's like the hydrogen crossbow, basically. New measurement. Yeah, but that's gonna be an ion. Of course, an ion. I don't know if sitting here just going through every single article ever written it's worth it at this point. As I already mentioned, the only reason why I want it in the video is because right here I'm explaining like why molecules exist, and it will be such a nice transition to be like, oh, according to this theory, actually helium hydride could exist. And only to then literally next chapter being about reactions.
I think it's not something you should bring up, given no one's ever talked about it.
Yeah, but that's exactly my issue. That's exactly my problem with not.
I feel like there is a very clear reason it wouldn't exist, and I just. I feel
like there's a very clear reason why no one wants to acknowledge the possibility that it could exist. And I think there are some pretty powerful people out there who really don't want others to know about helium hydride.
Yeah, big helium is suppressing this information.
Exactly. Big carbon. No, it's big carbon. They actually want everything to be... They want every molecule to have carbon in it, and helium goes against that. Coughing baby or hydrogen bomb. Does the baby have an incurable disease ninja? It's a crucial piece of information. He might get sued, but for 2.5 decillion, yeah. Listen, you are all laughing at my big carbon theory, but I mean, look at the oil industry. And that's like only a small part of the big carbon. The carbon lobby just holding all of the protons and neutrons? You'd be surprised. Okay, but I mean, there is one more angle at this. The fact that I cannot find the source is still so annoying. I could just find like a random... Oh, that would be maybe it. Like a random expert on the matter. Someone who's just been doing reactions with helium for the past 40 years and just bag them.
I don't think there's anyone who does reactions with helium, to be honest.
I know. I feel like there will be this one person, you know, that chemist who just spent his entire career just obsessing over helium. Just waiting for that one day when someone messaged him like, "Hey, what about helium hydride?" And then he texts me back like, "Oh no, we're not supposed to talk about that." And then the whole plot line unravels how it's big carbon.
It's more that there's probably just some extra details on molecular orbital theory that would make it really clear why it can't exist.
I know,
like just
but
a few principles, and I don't have them fully.
Yeah, the issue is, in order to find those principles, I would have to go through like 3 years of theoretical chemistry. Because these are probably because there obviously exist, like weak force, basically, for example. Like, the weak force affects the bonds. But at the same time, this isn't even chemistry, it's nuclear physics. So this is the border where, in order to explain this, I would have to probably go into particle physics. In order to make sure that
I would say it's still chemistry.
No, because
I
when
would
it comes to
say a smart enough chemist can easily answer your question.
oh yeah, I'm certain they do. I'm just thinking about how nuclear physics would still well obviously nuclear physics will affect its chemistry, but how in this case the protons themselves might have a major enough part in the reaction. Which yeah, chemists could still answer. To be fair, chemists do a lot of math and physics. 70% of big carbon is big oil. I would say it's no. I would say big oil is just a small part of big carbon. That's enough theorizing for the day, Grandpa. Let's go back to bed. No, oh kid, back in my day. I still feel like I should include it. Just I would have to
I
plop a
don't think you should
huge
without an
asterisk.
actual like expert opinion.
Yeah,
Because I think what will happen is a real chemist will see your video, be like, "What is this guy on about?" And
okay. There is okay, but here's the thing. Here's how I wanted to include this. This is the segment in which I talk about why molecules exist, why anti-bonding orbitals, phases for quantum numbers, so on and so forth. This is the segment where like, okay, why the reactions happen, which is basically energy of molecules, transition states, so on. And the way I wanted to include this is that according to what I've said so far, we could have helium bonded to hydrogen, in theory. But then right here, I would be like, well, actually, it's a bit more complex. And since chemistry is statistical physics, it being unlikely means it's basically non-existent. However, then I would need to, after that, add a huge asterisk and like, hey, funny enough, I didn't find the source for my claim and I'm just making shit up. Like and subscribe. I might do it actually. That sounds like a great plan. That's something.
The thing is, to me, I feel like it is actually just impossible. Like not just statistically, but I think there is some fundamental aspect. That
I know
makes
it feels like another explanation could be that you need that right here delta, the difference in energy, not only has to be greater than 0, it has to be greater than x.
What's x again?
I don't know. That's the point. Like, some sort of orbital interaction that you need to either overcoming the transition state or some sort of orbital interaction, or the protons pushing each other apart. So something like that. And so if delta E has to be greater than X, there is a genuine possibility that the delta E of hydrogen and helium is genuinely too low. However, since I have absolutely no clue what this X would be, that's basically 3 years of theoretical chemistry research just to find an answer for a silly question. And that's not only 3 years of theoretical chemistry research, that's 3 years of theoretical chemistry research that will be specifically targeting this question. The impossible molecule. Well, actually, Steele, do you have a source for your claim? Because I really need a source. Please have a source for your claim. Are you guys still talking about the helium hydride? Well, I'm talking.
I feel like you should just go to a chemistry server and ask.
That's a good one.
Someone will be like, "Oh yeah, it's just because of this," and that will be it. That will be your answer. Oh. And then once they say that, I'll be like, "Oh yeah, that makes sense," and I can explain it in more detail.
Oh, that's genius. Hold on, I'm in Prussian's blue chemistry server. That I don't know if that's.
Well, you gotta be careful because a lot of. Like, for example, if you ask anything in Nile Red server, it's like all the people there are like not chemists. But if you go to like explosions and fire, that's a group of chemists.
I see. Okay, there we go. I'm joining in.
There's also this. Let me send you.
Yeah, because the thing is, Prussian blue would be good, but Prussian blue, that's mostly like organic and so on and so forth. Organic and inorganic.
If they have a dedicated like chemistry questions or help channel, that's where you should go. Because if you ask anywhere else, it's gonna be some random answer. Yeah.
Also, really often people pretending they know the topic without actually knowing the topic and being like, "Oh, it's because it's a noble gas." I know it's noble gas. What makes it impossible? Because helium doesn't like bonding to anything or something like that. Well, it doesn't. It's not quite that. It's not quite doesn't like bonding. It's just that normally it doesn't gain any energy when it doesn't lose any energy. Well, it doesn't matter, figure of speech. When bonding with other things, and so basically, no matter what atoms you have, they usually have a separate configuration that's better than bonding with helium. Just read the sources cited in Wikipedia. I did. One of them is a paper from 1985 or something. It didn't help. Like right here, neutral molecule. That's what I'm looking for. And there are only 4 sources. One of them is the fact that it's the first entry in Gmelin database. Gmelin? I have no idea. I'm not a chemist. I just play one on TV. Stop chemistry. It is about the imaginations of madmen. I'll find the answer, no matter how much the big carbon doesn't want me to. Hi there, Elliot, by the way. Hi, welcome. Haven't seen you in a while. Again. Hold on. What I'm looking for? Yeah, right. 20 and 21, which means this. Oh, yeah. It's, by the way, also apparently. Oh, yeah. Flame, I don't know if you know that, but apparently it's somehow related to the 2001 Nobel Prize in Physics.
Oh.
That's when 9/11 happened. No, we're onto something. There is something. No, there is a mystery afoot here.
Let me send you something from one of those sources.
You mean to tell me that someone won the Nobel Prize in 2001, right when 9/11 happened,
look at this.
about hydrogen, helium hydride? I mean, wait. Oh, that's looks
the third source, number 21.
Number 21. Oh, okay, that sounds good. That sounds great. Oh, hold on, oh yeah, I remember why I didn't read this source, actually. This is the only source I didn't read because I couldn't... that was right when I asked you if you wanted to join, but you were busy and I couldn't figure out the website.
This seems like the source, so...
I don't know how university did, the professional research website work, because most of the time they need access, and I'm...
Oh wait, do you not have access when you go on that link?
I don't know. I don't know how to...
I can send you the PDF.
Yeah, alright, that's...
Wait,
is that legal?
Probably not. It's fine.
Yeah, okay, so now Flame will not send me the PDF, and I'm just gonna turn off the live stream, and I'm going to... There we go. So now that Flame is busy not sending me the PDF, I'm just gonna click through the website.
People do this all the time. Oh, you know what? I'll send you a link to a website, so I'm not breaking.
Oh yeah, authorization required.
Go to that website, Google it, and then put the link in there. Actually, wait. If I send you this should work, right? If you click on this link.
Site. Nope, authorization required.
Okay. Well, yeah. Go to Sci-Hub and input. Let me get the exact link for you.
Oh, isn't it the? Oh, that's what Sci-Hub is. Okay. Is that?
Input this into the.
Oh, I just inputted the other.
Either of them might work.
Yeah, I inputted the first one. It worked.
Yeah,
okay.
Everyone uses Sci-Hub. It's just free access to like most papers.
Wasn't Sci-Hub like? Doesn't matter. Yeah, I don't know. Helium hydride is one of the most energy.
It keeps getting taken down. They have a bunch of backups.
Listen, I'm on a hunt. All right, the big carbon is trying to keep this information away from me. Anyways, I hate chemistry, so I'll get it. Listen, I'm literally working on a video called "Chemistry Isn't What You Think It Is," because chemistry isn't what you think it is, and everyone who claims to hate chemistry is just talks about inorganic chemistry. And like, fine, I get it, but that's not the only kind of chemistry. That's kind of like hating physics because astrophysics just doesn't care about numbers. The pipe of the air. Okay. Which molecules are going to possible? Yeah. Bound excited states of helium hydride should exist. Oh, excited. Never mind. I knew that already. If I'm more accurate. Okay. Existence of bound excited states. Okay, so I don't care about excited states, right? That's obvious.
I mean, you kind of should. I mean,
Yeah, I'm on transition. Observe discrete optical spectrum discharge was not clear why the search for equivalent emission of failed. Report the first observation of such discrete emission spectra, which are the ultimate proof that bound states of helium hydride exist. Bound states, is it excited or just bound? Please don't be excited. Fingers crossed.
I don't know what bound states actually means.
We produced. Okay, no, this is helium hydride. It doesn't have an asterisk. That's not excited. Bound states were particle. Podcast things remain localized in more. Oh. It would make sense if it was this bound state. It would make sense. Imagine if this leads somewhere. Obviously, it leads somewhere. It leads straight up to the big carbon.
Okay, a bound state means that they're bound together in a way that energy is required to break them, to split it.
Okay, so
as in if you imagine like the energy diagram where it like goes up and down and stuff, there's some valley somewhere where it can sit in there and you need to give it more energy to go back over a hill.
Okay, so in this letter we report the first observation of such discrete emission spectra, which are the ultimate proof that bound states of helium hydride exist. I don't know if that's good enough. I mean, if it is not excited, just normal helium hydride, then that's actually exactly what I'm looking for. They exist.
But it could be that when they say helium hydride, they just mean the ion.
I don't think so, because we produced helium hydride by electron transfer. They differentiate between, they add the plus when they turn
Yeah,
our
but
ions.
it could be that they produce the neutral one, and that proves that bound states of the other one exist.
Yeah, but if they
charged
produce
one
the
exists.
neutral one, that still works.
Yeah.
I
need to read it.
I don't know how to read this sentence without interpreting it as we produce helium hydride.
Yeah.
Because they specifically differentiate between helium hydride and ion. I was very like on chemistry. Alright, Ali, bye. Have a good one, good night. We're still on the hunt.
Thing is, in the abstract, it says excited molecules were produced by electron transfer. So they are excited molecules. They're not.
Damn it. I mean, excited
I'm not
kind
sure
of
exactly
works.
what that means. If that just means like they're at high energy and
Yeah,
just
that's what I
drop back
assumed.
down.
So excited like hold on, excited I could make excited walk. Like that's I'm at the bargaining stage of the 5 stages of grief. That's where I'm at right now. Because I'm in. Wait, 3, 4, and 3 this. What's that referring to? Am I an idiot? I'm not used to
Free what?
3 and 4, like before the helium hydride. There's the number, and I don't know if that's a chemistry thing I'm not thinking of. Or...
That's the isotope of helium.
Oh, I see. That makes a lot of sense. Okay, so all right, so 4 helium hydride would be technically what I'm looking for. Yeah, carbon lines of different.
I mean, all of them are helium hydride.
Yeah, but I want only this one for it to be clean. I haven't mentioned isotopes in the video, actually. They haven't really come up, or ions for that matter.
The thing is, generally chemists just don't care about isotopes except for labeling stuff. Because isotopes don't really affect reactions. The only thing is that like isotopes will affect stuff like spin. And so you can replace, in certain molecules, you can replace hydrogen with deuterium, and the chemistry will be the same. But because you've changed the label, you've changed one of the hydrogens to deuterium, it has a different spin, so you can like see which one's been replaced in the molecule.
I need to get a class on spin, like what it actually does. That's the problem.
Does a lot.
I mean, I know, I'm aware it does a lot. I mean, it's basically magnetism, right? It's
yeah.
Yeah, but the thing is, I don't know exactly how it's magnetism. Like, as far as I know, it's just magnets. That's all I know.
Well, it's because so you know when you have like a moving charge, it generates a magnetic field, right?
Mm-hmm.
I think I'm getting this right. If you had an electron that were like spinning on its axis, in theory, that would produce a magnetic field, right?
Mm-hmm.
And in this case, the spin property does that. It essentially does that, but it's not actually spinning.
Oh, so
but it still produces a magnetic field from the charge.
If you have an electron moving, it produces a magnetic field. If you have an electron spinning, then that's kind of like electron moving producing magnetic field. And so spin, even though it's not spinning, it spins, so it produces a magnetic field.
Yeah, and that's why they thought it was spinning in the first place, and they called it spin.
I see. Okay, that's actually makes sense. Makes a lot more sense than I expected. Yeah,
and so then once you have that, it's essentially like spin, like in a material, you've just got a bunch of tiny magnets, right? Like they're pointing one way or the opposite way, and they will generally just average out and completely cancel out. But in certain materials, they can align a certain way, and then if they're all aligned in one direction,
that's kind
then
of
you
like
have a magnet.
Yeah, that's kind of like just a copper wire in which the electrons are just chilling versus a copper wire in which you apply a potential, so they're all on average moving in one direction. And so the same way it's with magnets, except you don't get them moving in one direction, or you align them all with spin in a certain direction.
Yeah, so they're all spinning, but rotating the same way.
It actually makes a lot of sense. It really does now.
It's really easy if you just imagine they're spinning and don't care about the fact that they're not.
It's really easy when you. I mean, the thing that clicked the most to me, it was the realization that it's like an elementary thing. I don't know why it took me so long for that to click, but that's what helped me the most. That's why whenever I explain spin to anyone, I always start with the fact that it's elementary. You cannot, just like you cannot understand charge, charge is actually great to explain this. Charge is absolutely great at explaining spin, in my opinion, because charge is something that we all know. We all understand what charge is, but at the same time, you can't explain charge. There is no explaining charge.
Yeah, it just is.
Yeah, so basically, spin wouldn't be confusing if we just didn't call it spin. That's kind of like calling charge just electron gravity, and then each time you explain electron gravity, you have to be like, no, it's actually not gravity. It's not gravity for the electrons. It's different. But we call it electron gravity because it behaves like gravity.
Has anyone ever explained to you the difference between different values of spin? For example, a photon is spin 1 and an electron is spin half.
No.
And there are some other particles that are spin 2.
No, absolutely not. All I know is that when you have a single electron, it can, I think, be... Well, I think you can correct me right away if I'm wrong. Spin of positive half or negative half. I think.
Yes, I'm talking about the magnitude, not the. The direction.
No. All I know is that when you have a single electron, it can be the positive half or negative half, and then when they interact with each other, then they can have different combinations or whatever. I don't know why a photon has one and
that's because you're adding the spins up, and it's called coupling. But that's when you have more than one. There, I'm actually talking about particle physics here. So just one electron.
Okay, so why does it have 1.5?
Well, I don't know why, but I can explain what they mean.
Okay.
which is so I don't know why, because they are
Elementary.
fundamental properties, and it's like you define that particle as, oh well, an electron is a,
Yeah, it's kind of like asking why
-1
this
spin
electron
half.
has a
Yeah,
charge of -1.
yeah, that it just is. That's what an
It
electron
just
is.
does. Yep.
Let me can I do this whiteboard thing. This thing is so convenient in Discord.
3DS.
Oh, it's got the same drawing from before.
Does it? Like,
It's got these angles.
oh, for me it's... Oh, never mind. There it is. Okay.
I'll delete them though.
Oh, I
Keep
was
the face in the
explaining...
top right.
No, we actually
Um,
should add another one. Just...
Oh, yours is really zoomed out. Okay. So I need to make sure I get this right. I basically taught myself this by watching YouTube videos that explain it. Because I got really curious about spin after after you went on and on.
You learned this from YouTube videos. Now you're gonna teach this to me, and then the cycle continues. I make a video with spin, and so we carry on.
I'm just checking something. Give me a sec. Okay, so let's say you have an object, and if you say you have an object that's like it looks like a square, right? This is our object,
Right.
and every time I'm trying to think how to put this. Oh, I'm trying to remember the analogy. Hang on. Give me a sec. I need to think.
In the meantime,
Okay, if you do a quarter turn with this object,
yep,
you end up with the same object, right? Like it still looks like a square.
yes,
And so that means you can do 4 turns in real space, but each of these turns gets you back to the exact same thing you started with. And so we'll say this is spin 4. You don't need to worry about what the spin bit means. And then say you have another object, which looks like a rectangle. When you spin this, you can do a half turn, and you'll get back what you started
so
with.
Be S2?
So you have, yep. So spin 2, and if you have another object that looks like, trying to think how to draw it. Looks like this. This object.
Spin 1.
What do you think? Spin 1, right? Because you have to spin it once in real space to get back to what you started with.
Okay.
And then we run out of things we can draw here, but our electron is spin half. And so what this means is that if you spin it once in real space, you've only done half a turn of what the electron can actually do, and you have to spin it twice again to get back to
Oh
what
my
you started
goodness,
with.
this is such... Okay, I get it. Oh, it's actually a pretty great explanation for... I think I can see where you're going with this. Like, I think...
Yeah.
Where basically you need to hit it with a photon twice in order for it to...
Not really, no.
No? Then never mind. Never mind then.
I wasn't sure where I was going, to be honest. I remembered this analogy.
Because, I mean, this analogy is pretty killer at explaining what spin half would mean, because I don't know. It's not something you can imagine, is it? You can't really imagine an object with spin half.
Imagine. But what you can imagine is that this spin 1 thing, this is a property that photons have. They have spin 1, and so we can treat the photon field. So, if you imagine, instead of
Quantum
imagining
mechanics.
a particle, you have a 3D space.
Yes,
that's made up of values, right? If you have a spin 0 space, so So say this is your space, and at every point in space, you can have a different value. If you have a spin 0 space, each of these points will give you some number. Like each of these points is a number.
Yep.
If you have spin 0. But if you have spin 1, each of these points is a vector.
Okay, so is it tensors then? So if you have spin 2, it's going to be not a matrix, only a tensor?
I actually don't know what a tensor is. My physics sucks.
Oh, tensor is like vectors only the other way. So, if vectors have like a one line of numbers, then, so, you have a vector, which is, I don't know if it's called first order, but that would be first order tensor, then
okay, yeah.
second order tensor.
The second order tensor,
I think
the
that's what it's
matrix,
called.
right?
I think, yeah.
If you have matrix, which I think I've seen it drawn kind of like this, even though it's not really like this. This is your spin 2.
And then spin 3 would be the higher order tensor,
Yeah,
and so
the
on and
higher
so forth.
order one. But you can see with this trend how you can then go to spin half using kind of coupling these two analogies to each other.
I like how
it's a very weird.
I love how neither of them make sense if you think about it. Actually,
yeah.
I love how this is great because the more I learn about spin,
the worse it gets.
The worse it gets, really. I mean, oh wow. Hold on, let me just first. Does this count as physics or chemistry? I can't even tell. That's the beauty of theoretical chemistry.
This is very much physics.
Yeah, but the topics we've discussed so far, that's kind of blurs the line at this point. Because the fourth quantum number, for example, I would argue that's more theoretical chemistry rather than quantum physics. And that would be my argument, at least.
I would argue it's chemistry once you start combining more than one atom together.
Yeah, but the thing is, with a single, you can't really do much with just quantum numbers by themselves in a single atom.
Yeah.
It's...
they're tools for chemistry.
Yeah, at this point, we're talking about two hydrogens with a single electron, which, to be fair, we're still struggling with this, but even in physics, we're talking about two hydrogen atoms with a single electron. The founder's thing is called, is still Can't Say Bad, Let's Make It Happen. I know, I can't change it. And you know what? I love that name now. It's a great name. Okay, so hold on. I get these two explanations. They don't make sense, but I get them.
Yep.
That's actually a sign that I get them because they don't make sense. This is so dumb, by the way. It's like, okay, you know how dimensions are, right?
I do know what a dimension is.
Yeah, made a whole video about it. I don't know if you've seen it. But
not sure.
Okay, so that's a no, alright.
wait, which video?
Let's do physics in 7 dimensions.
Oh yeah, no, I have seen that.
Yeah, so dimensions are just multiple numbers.
Yeah, have I actually didn't watch it. But
Ouch, heartbroken.
I will watch it.
Heartbroken, and will just cry myself.
It's because I enjoy 4 dimensions.
You don't have
7
to...
is a bit many for me.
Yeah, if it was 6, that would be spot on. I know.
I'm quite happy being like confident that I can properly picture and utilize a 4th dimension, but I think 7 is...
Oh, the thing is,
far.
actually, 7... Let's do physics in 7 dimensions was a case for why you don't need to picture dimensions to do anything in them. So basically, from a computer scientist perspective, rather than from... So basically...
Oh, okay, I can get that from the computer science perspective.
Yeah, it's basically... because
Did you use this stuff with the tensors then?
Oh, actually I haven't, because tensors don't matter, funny enough, when it comes to dimensions. That's because when you have a vector, right?
Oh, I would have thought they would be like useful for
Actually,
adding
I mean, they
dimensions.
kind of are, but not really. The reason why is because when you have a vector, the more dimensions you add, the further down you go. But tensors are like exponential. So, that's the first order tensor. Third order tensor would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can't see it, but 3-dimensional would basically.
Okay, yeah.
So tensors Tensors would be good if you added new kinds of dimensions. So if we had 4 spatial, 4 temporal, and 4
Okay, I get
magical,
it.
then
So,
I
like,
think
each
that's
value
where.
is a dimension.
Yeah,
but
I'm
you...
completely guessing right now, by the way,
Yeah.
but they don't actually matter. So no matter how many dimensions you have, you can describe all of them with a vector. So
Okay, I mean that makes sense, I guess, because a vector in like 7-dimensional space will still have
just 7 numbers.
Yeah, 7 numbers.
Exactly.
Right.
So the point of that video basically was that you know, when you hear someone doing physics and basically the motivation was because really often when, you know, people say something like, oh, I did physics in 7 dimensions, sounds impressive, but in reality it's just physics in 1 dimension multiplied by a 7-dimensional vector. The math doesn't change.
Yeah.
No matter how many dimensions you add. So the reason why I started this is because this spin is basically kind of like having a dimension of 1.5. And because, yeah, what will be dimension 1.5? Well, a vector of 1.5 number, basically.
Yeah.
But funny enough, in mathematics, you can have a dimension of 1.5. You can have an irrational dimension, if I'm not mistaken. It has something to do with fractals. But so it really has that same vibe where I just feel like you chemists just let a fox into the henhouse and you let a mathematician do something for once.
Yeah, we look at all the weird stuff, we're like, ha, that's funny, and we just use it. We don't care about how it works.
No, I feel like there was a single mathematician who pretended to be a chemist and they just snuck in, pretending to be a chemist and a physicist. They just snuck in, invented spin, and no one's questioned them ever since. Everyone pretends like, that's physics, that's chemistry, definitely not math. This is what happens when Grandpa does take his meds or go to bed on time. I mean, spin is wild, because with every new day, I learn less and less about spin. I unlearn things as I go on. I like non-integer dimensions. I don't actually quite get what they are. I just know they have something to do with fractals and how... well, I get they have something to do with fractals. I mean, I know what they have to do with fractals. If I'm not mistaken, it's basically like when you have a line, it's a 5. When you have a square, it has area of 25. And when you have a cube, it would have volume of 125. If I'm not mistaken, it's this. Except right here for each dimension you bring it to a power. I think it was something like that.
But what is this?
Oh, this is just volume, surface area, surface.
Oh, okay.
Actually, wait, hold on. So, because there's only one thing missing from you when it comes to spin.
Mm-hmm.
And that's application. Any application. Absolutely anything. Have you
application, magnets, EPR spectroscopy, NMR spectroscopy?
EPR spectroscopy, for example. Do you know how, when it comes to EPR spectroscopy, how spin affects everything? How it makes it work, I'm assuming.
Let me pull up my presentation that I gave on EPR spectroscopy and the theory.
Convenient. I do remember you talking about that presentation. This is the old one, right?
Yeah.
I do remember that. Wait.
It's on my Google Drive because I reset my PC at some point.
Wait, actually, what does the negative dimension look like? Well, mathematically, it wouldn't... Well, what would a negative dimension look like is a physics question, and physicists wouldn't let you do a negative dimension. But mathematically, I'm pretty certain it will be just this going the other way. I'm fairly certain. I don't have it. I am, by the way, going to use this as a source. I just want to... Because, like, if they... I stand by my claim. They said we produced helium hydride by electron transfer to helium hydride ion. They specified ions, and I don't even care if it's excited or not. I'm gonna take any win I can get at this point.
They yeeted electrons at it, and they managed to.
Hey,
they managed to get
worked,
a spectrum before it collapsed.
Hey, technically it existed. Haha.
Yeah.
Technically, it was.
Let me just check that I'm not doxing myself on this.
Yep, that's reasonable. MAKiT should accept the invitation more for future streams. I should. The problem is I haven't... This is... I'm working on a chemistry video right now, so it's convenient, but most of the time I'm just working on boring math videos. Much maths. My channel is suffering from a maths poisoning. I don't care that no one wants chemistry videos. Y'all are gonna enjoy them. I'm gonna keep on making them. Until the viewer count dips into negatives, I'll keep on making chemistry videos. And next one will probably be about inorganics. That would be fun. Hate chemistry. You don't hate chemistry. What do you mean hate chemistry? That's such a broad... Chemistry is such a broad thing to hate. Do you mean you hate chemistry or you hate inorganic or organic chemistry?
Doesn't let me paste images in the thing. Do I have to save the image and then...
Oh, boards can be saved up to 90 days. That's a lot of days. I feel like we should keep this. Can we expand the board or... No, I don't think so.
I don't think so.
We kind of wasted a lot of space.
We can just zoom in infinitely in one spot.
Oh,
and then,
can we really?
I think so. Oh, there's a limit, but you can zoom in quite far, and then
yeah, it's good enough for me.
and then it's technically a bigger piece of paper, right?
Yeah, I feel like we should keep it. I like the idea of just having absolutely unusable board. There we go.
Where are you zoomed in on, so I can zoom in on that?
I can just zoom in on. Yeah, I just put whatever,
okay.
and there we go.
Okay, so what this diagram is showing, you can see my pointer, right?
Mm-hmm.
So this is the energy of the two electrons before you've applied a magnetic field.
Right.
And as you apply a magnetic field to the sample, and as you increase the magnetic field, so that's what you're doing on the x-axis here, the electrons change energy because one of them is spin plus half and one is spin minus half, and that affects their alignment to the magnetic field.
Okay, so can I think of it as like you have one electron spinning left and one electron spinning right, and if I apply magnetic field going from right to left, then it's going to speed up the electron spinning left and it's going to slow down the electron spinning right. I know that's absolutely not what's happening.
I don't know if speed up is the right...
well, speed up because there isn't really an... I know it's not the right word because spin stays the same, but I just said speed up because I... Like, what else could I increase with energy?
Let me check something.
I just love the analogy of, hey Flame, so in this scenario, which is absolutely not what I mean, would this would this work? I see a delta. Oh, the siphon delta just means difference. So
yep.
Delta E just means difference in energy. That's all it is. It's just easier to write a triangle down than say difference, but it is always just difference, practically always, unless it's delta upside down, in which case run away as quickly as possible and hide. Not a function. Yeah, it's not a function. It's just difference. I'm here for math. You've shown me nothing but pain. This is spin. The only reason why people research spin is because they want pain. By the way, I'm failing my chemistry class. I'll take them. Actually, I should make an inorganic chemistry video. I'm gonna make that next. Well, not literally next. I'm gonna make that next when you'll vote for it. Might be in a couple of years. I came from MAKiT. Now 32 people are the exceeded.
I'm almost on my... I've almost clicked with the explanation. Give me a sec. I need to fully brain power this one.
It's fine.
No, because I did understand it and I've forgotten.
It's fine. It's spin. Listen, you don't need to explain.
I will understand it. Give me a sec.
Do it on ideal gases. That's chemistry. That's thermodynamics. Well, kind of chemistry, I guess. Only if you're delusional.
Because I'm sure this professor explained this.
This chemistry, though. Thermodynamics is about as chemistry as astromechanics are astrology, okay? I had sushi last night. Do I do sushi again? Do you like sushi? If you do, just go for it. Where's law and the other one? Yeah, them three laws just combined to the ideal gas law. Japan, what do you think? Can you please explain upper and lower bounds there's time in the stream? What kind of upper and lower bounds? You mean mathematical or different kind? Oh, I like your nickname, Stetzels Pretzels. That's fun. Math. Calculus. Oh. Are we talking about the same kind of bound? Hold on, let me check. Is it the one where you limit a function? Of course, mathematicians just have to complicate everything with set theories because, you know, it would have been too easy otherwise. Isn't this just a limit?
Ah, I think I get it. Okay. Can we go to the electrons, the EPR thing?
Mm-hmm.
So, if you imagine, so the electron spins, and that creates a magnetic field, which means the electron acts as like a mini magnet, right? Like a bar magnet.
Mm-hmm.
And if you hold the magnet at an angle, so say you're holding a tiny bar magnet, and you stick your hand holding it inside a massive magnetic field machine,
Right.
you're going to feel a force, right, when it turns on,
Mm-hmm.
because your bar magnet wants to be aligned with the magnetic field of the machine.
Yes.
And so what happens is if it's aligned properly, like in the nice way, it's going to lower the energy of your bar magnet in the sense that your hand isn't going to feel any force because it's where it wants to be. Whereas if it's aligned the wrong way, it's going to feel really bad because it really, really wants to flip round and align the right way.
Yes.
Which means that the energy is going to increase because it's unstable and so it wants to fall down in energy.
Yes. Okay.
And so then that's what's happening in this, where your electron is like a tiny bar magnet, and if it's aligned the right way, the energy is going to decrease. But if it's aligned the wrong way, the energy is going to increase.
Mm-hmm.
And so that's what causes this energy change.
Wait, so wouldn't in this case... Wait, so does this spin work as in like magnetic charge? Obviously it wouldn't be identical to electric charge, but I mean analogous to... It's kind
What
of...
do you mean?
Well, you know how...
The spin is a direction.
Well, yeah, but when it comes to application of spin, does it function like charge? So, for example, you know, when you have an electron, electron charge, the way we apply it is when, you know, it comes in contact with negative charge, it's going to repel. When it comes into contact with positive charge, it's going to attract. So the spin would work the same way, except with magnetism. So when it comes with into contact with a magnetic field that's aligned in the same direction, then it's going to... Wait, no, because the energy is going up.
Well, I think the energy decreases when it's aligned.
Okay. Oh, so in this case, it's.
Yeah, I get what you're asking.
I should have warned you before asking about spin. Actually.
Uh,
My brain's about to have a heart attack because of this. I can say, I'm having fun. I can only assume everyone else is having fun too.
let me show you a thing. I hate that it doesn't let me paste. It's actually really annoying.
How did you add the image then?
I had to save it and then
Oh, that's so
upload
dumb.
the file.
That's so dumb. Listening to Mozart and Flame explaining chemistry while doing my math homework makes me feel big brain. I would just like to mention that for everyone who doesn't understand what we're talking about, or rather what Flame is explaining to me, this is some advanced chemistry stuff, like truly advanced. So don't go hating on chemistry because this ain't easy.
This is barely chemistry. This is
This
is
like
it
theoretical.
is basically the physics required to do some chemistry. Okay, I mean you can have a read through this. It doesn't fully answer the question except for a bit of maths, which
Actually, that's good. As I mentioned, I'm looking for the application. So, the magnetic field moment the electron interacts with the magnetic field causes Zeeman reduction. And like classical laboratory-sized bar magnet, the magnetic moment of the electron cannot be placed at any arbitrary rotation relative to magnetic field. It is restricted to two positions, both in reality at an angle to the field, but usually referred to as up and down.
The angle stuff I haven't talked about because it's an extra thing, but it's relevant because it's quantum.
Okay, this occurs because the component of the moment along the field direction is quantized. The magnetic direction is... Right, so we have the magnetic quantum number. So it can be positive and negative, right? There are two limitations relative to the axis. The z component, as known, but the x-ray components are not. I remember that from my actually funny enough nuclear physics research. This basically paragraph right here. I remember that from nuclear physics. The spin vector lies somewhere in the cone. Yeah, okay. Am I moving this or am I moving myself? The magnitude of the spin vector was given by S is equal to this. Shuffling H while I'm walking into atomic units gives the magnitude of S as this. Cool. Similarly, the magnitude of Z component. Alright, numbers. I got it. What's the difference?
This is just to get the actual
values, yeah.
Physical value of it, but we don't care about that usually.
What is the difference between two spin limitations? The field, the energy. Oh, that's okay. So that's important. The difference of interaction of between hold on. The energy of interaction of between the magnetic field and the electron's magnetic moment is this, where B is the magnetic field and other vector quantity. Okay, so its energy is equal to negative. What's the mu here for? What's mu supposed to represent?
Let me have a look.
Constant. Is equal to negative GE beta
mu
S
is the
divided by H.
magnetic moment, which I guess doesn't mean much.
Is it the constant or
is it the what?
Is it a constant or like a...
No, because it depends on spin. Depends on S.
Oh, I see. So it's negative
constant
spin
for the
magnetic
electron,
field.
Yes. Huh?
It's basically negative spin magnetic field. If I disregard all of the
yeah, pretty much. Yeah. Mu depends on S.
Okay, so energy is decreasing So when I have a certain spin of the electron, the energy is decreasing as the magnetic field is increasing. But only if the spin is also like so. Why do I keep moving?
If the spin is negative with respect to the magnetic field.
Yeah, so if I have a negative 0.5 spin, I don't know why I drew the arrow, there's no point to the arrow, then energy would be equal to negative 0.5, and so this gives us a positive, which means in order for us to lose energy, we would need a negative magnetic field.
The thing to remember is, so say this is your magnetic field, and it's facing this way. You are taking this component of the spin, right? You're taking this component in the z-axis, which is our axis of the magnetic field.
Yeah.
Yep. So just to clarify, the value
I don't know,
isn't our 0.5. It's whatever this number is.
Yeah, so this would... Okay. Oh, I see. Oh, okay. So, in this case, I don't remember trigonometry, but basically...
Yeah. But yeah,
wait, no, yeah. H, A, B. In this case, this would be H, and in this case, we would care about...
Yeah.
This should be A.
Yeah.
All right. So, okay, but I get it. So, basically...
that's shown
spin,
in this diagram here.
So, if spin is aligned... If spin... is aligned with the magnetic field. So if they have the same symbol, if they're both minus or if they're both plus, then the energy is decreasing.
The thing is, the field can't be minus because what we're doing is we're making our z-axis the axis the field is facing. Like that, we're defining this axis as the field.
Okay, so... Okay, but still, my point... Okay, but I am thinking that changes my understanding of this, because...
No, it doesn't, because it's still then...
Good.
It will
so
either
basically,
be aligned
if it's...
or not aligned.
Alright, so if it's aligned, then energy decreases. If it's unaligned, it increases, which means if it's aligned, then it's chilling, that's good, it's already aligned. But if it's unaligned, then it wants to be aligned, so more energy.
Yes.
Okay. Alright, almost there.
The thing that doesn't sit right with me with the analogy is, and this is going to be painful for you because you misunderstood it, but the thing that bugs me is that even if you have like one that's aligned, how does this decrease the energy compared to just not being aligned? That's what you do. Get what I mean? Like, compared to no field, how is this decreasing the energy by just adding a field? That's the one thing that annoys me a bit.
I don't think I get it, actually. Oh, because it's decreasing the energy without actually doing anything.
Yeah.
Oh, I see. Okay, I see now. That's a good question, actually.
I think it's a maths thing.
Yeah, it sounds like just don't ask questions. It's elementary. Yeah. Trust me, bro.
Yeah. But yeah, so this is our thing. So it either points down, and just to clarify, because it's quantum, it can only be this angle or this angle, right? It can't be any other angle.
That's in a single electron.
Yeah.
Because then they also can combine to do whatever.
Yeah, you start adding the vectors pretty much, because then if you start combining them, you can get like this.
And then you get and then you just get all possibilities.
You don't get all possibilities, but you get more possibilities.
All right.
So you start coupling spins together. I get why. Essentially adds up the spins, and gives you potential values within a range, but those values are integers.
Wait, so what is the rule for the possibilities that you'll get if you add spins together?
I've shown you the rule. Let me find the... I've specifically shown you the rule.
I only now am beginning to understand what spin is, okay? I do remember you showing me the rule. I remember that was like one of the first live streams when you joined in. I remember you showing me the rule. But I don't get what...
Is it this?
I still didn't get what it means.
Not this. Is it this? Aha. It is this.
Be patient with me. I lack basic understanding of chemistry. Be patient with me. I'm a YouTuber. I should have a hat like that.
Okay, I can screen share this. Just checking I'm not doxing. Yeah, okay, that's good.
Okay.
So this was from inorganic chemistry. This is on our magnetism stuff.
Right.
But it actually, the whole beginning bit is the same as what I was showing you. So this is the Zeeman interaction, where it splits and some stuff. Does it explain much more? I'm just gonna have a quick read. Magnetochemist.
Sounds like a super villain. Oh, I now got it with the spin 1 of photons, by the way. I only now got why. Okay, I get why photons would have spin 1.
Why?
Well, from my I can give my argument why I feel like it makes sense for photons to have spin 1 because like it was the whiteboard. How do I full screen the whiteboard? How do I what? Can I not just? Okay, so I apparently gave up on the. Oh, there we go. So, because when you have like an axis and then having spin 1 basically means that it will be aligned with, when be white is not a great choice of color, means that it will be aligned, so it would have to be like infinitely long, right?
Can you repeat that?
Because so spin of 1 would basically mean that the arrow would be pointing straight up.
Yep.
And I mean, okay, I lost it right away, but it makes sense. I cannot explain the why, but it makes sense for me that photon would be aligned. Wait, no, just carry on. I need a second. My brain is overheating.
I'm just thinking because there was an analogy to do with the stuff I showed you.
You mean with half spin?
Yeah.
How it may?
Yeah.
Flame. Those analogies are even less helpful. I love how every single analogy for spin basically produces the exact opposite effect of what the analogy is supposed to do.
I'm just trying to think. Because if you remember the thing about like you have to rotate it twice
Yes.
to get back to where you started, that means that when you do a full rotation, you've gone to like the opposite state, right?
Mm-hmm.
So I kind of picture that like you're going from plus to minus half, but you're still like in our real world, we've rotated it around and you've got back to where we started, and there shouldn't be anything different. But the electron sees something different. The electron sees itself as in completely the opposite orientation.
I mean, there is one way to do it. There's like one kind of rotation. There is 3-dimensional rotation, which would make sense here. However, it would make sense graphically, but it wouldn't exactly make sense mathematically. I'm pretty certain.
Yeah. This is the stuff about adding spins. Does it?
I feel like I'm too stupid to be listening to this conversation. Still, that's not the problem. This is just spin.
Okay, so this isn't adding up electrons. This is adding up nuclei. Well, okay, nuclei that have electrons, right? So essentially, this ion has spin 5/2 because you've added a bunch of electrons on it, and that is apparent if you look at, where is the diagram? If you look at this, these are all our electrons in the orbitals on this ion. The
right.
ion. Yeah. Okay. all these electrons are unpaired, and so our total spin is 5/2 because we're adding up these halves, right? Because if you had an up and a down, they would cancel out, but these are all up, and so we're adding them. And so our
Right.
magnitude of the total spin is 5/2. But the thing to remember about this is that each of these could be down, and that would lower our total spin, which means that in reality, the actual spin values we have they range between 5/2 and -5/2. But the values you can take in between are all integers. They're all separated by integers. Because if you imagine you flip one electron, then your spin decreases by 1.
Yeah, but isn't this just all combinations? All possible combinations?
Yeah, that is all possible combinations fall between the range of 5/2 and -5/2.
Oh, so it is all possible combinations.
Yes, but we say that the magnitude, the overall spin of this is 5/2. But that when we say that, we as chemists understand that that means that it has all these different spin states that it could be in.
Okay, I see. So that's kind of like quantum physicists saying that's not something quantum physicists do because, well, they're not chemists. But no offense. But that's kind of like if a quantum physicist said that a particle is at some point, and what they actually mean is that at this point the wave function has the highest value. So the spin, when we say 5/2, we don't actually mean 5/2. We mean like we mean 5/2, which from which you can get all the possible spins.
Yeah. If you look at this, these are all the values we could have, right? And each of these red arrows is like you've added up the 5 arrows of each electron, right? So this is if you had all of them pointing up, they would all add up to make this. But if you had one down, then they would cancel out and you'd get this. If you had another one down, it would be this. And if you had 3 down and 2 up, it would be this. And then 4 down and 1 up, this. And all 5 down is this.
So if I had 6 electrons, if I combine all of them, would I say that the spin is equal to 6 seconds? However, it has 7 possible states technically.
What do you mean 7 possible states?
Like right here we have 6 possible states.
Oh, there was this. Yes. Yeah. So you're saying if you had 6 halves, you'd have 7 states, right? Because 2 times 7, 2 times 7 halves is 7. Sorry. If you had 6 halves, is what you're saying. 2 times 6 halves is 6 plus 1, 7 states. Yeah.
I get it. Wow, that's... I remember months ago when you showed me this for the first time. It took me months. It took me literal months.
I mean, this stuff is hard to understand.
This
like,
is
I explained it to you, and
understand.
I have to look at this and think quite hard about what's
I would
going on.
argue this is borderline impossible to understand. Oh wait, hold on. There's a distribution, right?
Oh, this
I remember when you mentioned that.
I remember
when you mentioned that, and that was the one thing I actually got.
Yeah.
Where was it in absolute 0 when it's all on the -5, or was it not? Absolute
so
0?
this is when we have our magnetic field on it. What happens is instead of all these energy levels being the same energy, they separate, and some go higher and some go lower. Right.
Right.
This is our Zeeman effect. So the same thing from the where I showed you with the 2 lines splitting, but except this time we've got 6 lines. And so yeah, some of these are lower energy, and so it wants, you're going to have more in the lower energy stuff, and there's going to be some kind of distribution that spreads them out. And the more heat you give to the sample, the more
evenly distributed it will be.
Higher up. Yeah.
Wait,
so
is it
in
more
theory,
higher
if
up,
you had
or is
infinite, if you had, I think Okay, you're about to ask if you had like infinite heat, would you
Yeah.
have them all at the top, or would they all be the same? Right.
Yes.
I'm not sure.
Okay, I see.
But if you had no energy, they would all be in the bottom. I can tell you that for sure.
Oh, that's what I remembered. Yeah, when you have absolute zero, they're all at the bottom. I remember that.
Yeah. Yeah.
This okay. I see. Oh, all right. So hold on. So if you have spectro, wait, was it? Oh, the thing I started with when I asked you for
EPR.
EPR. Exactly. Yeah. Thank you. When you do EPR of something in absolute zero, does the energy only go down?
In absolute zero,
Yes.
yes.
I was full on
Because the
expecting you.
electrons, I mean, well, yeah, the electrons have to go down here, right? Like they can't go anywhere.
Okay, I was full on expecting you to just to to just correct me because I didn't expect to. Okay,
And actually, EPR is done usually at cold temperatures, but I don't know if it's because of that. I think it's because of something completely different. Um,
huh. This is wild. Wow. Okay. Um.
I have a friend. She's doing an EPR project, and she was complaining that she was using some sample that had been frozen into ice in liquid nitrogen, and she dropped it into the EPR machine, and she was
Oh.
panicking because she didn't know how to get it out.
Oh, that's actually awful. Wait, was it? Oh, is it? Was it frozen? So was it liquid by default? By default in room temperature.
Yeah, yeah.
Oh,
All
that
the stuff we work with
sucks.
is liquid. So I think she was panicking because it would like melt, right?
Yeah, with melt there would be well fine knowing to clean up, I imagine. Okay, I I get it now. I don't get it perfectly, obviously, but I finally understand what spin is, why it is, and how it is.
Yeah.
Now I want chocolate milk. Yeah, I actually.
I'm not gonna bother explaining this stuff. This stuff was annoying. I don't know how, but I got 90% on this exam, and I don't remember half of this.
That's actually how. That's just. And that's
I
actually
know, but
quite
I actually
poetic.
found it really interesting. That's the problem.
Quite poetic. Oh, and then magnet. All right, so magnets are strong when all electrons have a line spin. Wait. Oh, hold on. Wouldn't
Oh,
then?
you're looking at this?
Oh no, that's from what you
Okay, no.
said previously. Because then, hold on. Wouldn't that mean that like the colder something is, the more magnetic it is? To oversimplify.
Yes. You're looking at this.
That makes a lot of sense.
Um,
Actually, that's
Magnetic susceptibility, yeah. So when you lower the temperature, more magnetic susceptibility.
that makes a that actually makes a huge amount. Oh, and right here you can actually see the distribution over different. Yeah, so of hold on, if you lower it down back to this graph, the corner would be zero, correct?
Yeah.
So from this graph we can get that
wait.
if you had
1 over temperature. Wait.
actually is it zero?
This is you're lowering temperature as you go to the right.
Yes, but where does it start? Does it start at zero?
It's starting at infinite temperature, and then you're going
Yeah,
1
so
over temperature.
so if it starts zero, if that's infinite temperature, which means right here we can tell what the distribution would be. It would be uniform.
Yeah.
Good.
Oh, this answers your question from before, where you weren't sure if they would be higher.
At
Yeah,
infinite heat,
they're just uniform. Yeah.
this is uniform. That's that everything. Wow, it's almost as if it makes sense. It's almost as if chemists aren't just
Yeah, I mean, you can
shit
imagine
up
it like in if you have like a I don't know a block of iron, right? And you have all these electrons that can be facing in different directions. Then, if they're at a really high temperature, they're all going to be completely randomly distributed in the directions they face, even if you put it in a magnetic field. because they have enough energy to face in completely random directions.
But when it comes to absolute zero, they
But yeah,
have
once
no
you
energy.
cool it down, the electrons don't have energy to go in this misaligned direction, and so they will just align with the field.
Yeah, so basically, if they had some energy to go against each other spin-wise, then they wouldn't use that energy to go against each other spin-wise. They would just have higher temperature, because that's what it is. That's what temperature is. It makes it. Yeah. Okay, imagining them spinning helps.
The
It's
thing
like,
is, you don't need to imagine them spinning. You just need to imagine them as bar magnets because it's the same effect.
honestly,
Because the spinning produces magnetism.
for me, it's easier to imagine them spinning. Okay, not really
Here's
imagine them
your
spinning. Only imagine the arrow of spin. I know,
Yeah,
actually, imagining
yeah.
them spinning makes things so
Yeah.
much harder.
It's literally this. So it's like it spins and that produces a magnetic field, and you can define this or this as an arrow, and it's the same thing.
I like it. I'll be honest, I like spin now.
Let's go.
I hate spin, but it makes sense. Wait, hold up. How does Flame know all this? Witchcraft, I'm assuming, actually. Flame claims that he like researched this and studies this and whatever, and apparently he's a chemist or something. But no, it's witchcraft. We all know it's witchcraft. It is fun. I like spin now. Maybe it's just because I've been.
I showed you this stuff before, but I think
Yeah,
you,
but
it
I
just had to take a few months.
exactly. I just need to ferment for a couple of months too. To be fair, that's okay. Actually, hold on. You showed me this before my entire, chemistry arc. So, can't really blame me for not understanding anything.
Yeah.
You've shown me this before I even knew about orbitals, by the way. Knew what orbitals are.
Really?
Yeah, that's actually.
Well, I get it's not relevant to the orbital stuff.
Yeah, but still, orbitals are much more obvious than spin.
Yeah. Yeah.
You have to remember, I'm not a chemist.
Well, it's also like for the chemistry, we don't care what the spin is, we just care what it does. And in this case, it lowers or increases the energy.
I feel like it's not really that you don't care what the spin is, you only care what it does. I feel like it's impossible to care what it is, so we just care about what it does. Like the same with charge.
Yeah.
Technically, when you're doing chemistry, you don't really care what charge is, you only care what it does.
Yeah.
That's because, Grandpa needs to spin his way to bed. Grandpa is happy.
I do actually need to go to bed.
It's fine. I understand. It's really late. It's completely fine. Thank you so much.
Yeah, I've got a lecture in the morning, but I'll be chilling.
All right. Thank you so much for explaining spin to me for the last time, hopefully.
Oh, there will be many more times.
I mean,
I know
yeah, yeah. I'm lying to myself. Anyhow, well, thank you so much for joining. Anytime you
yeah, no
feel
worries.
like it, just channel's always open.
Sleep well when you decide to sleep.
All right. Bye. Have a good one.
Bye-bye.
Good night. Well then, I am. Oh, my Discord glitched again. That's festive. And I still have a struggle to understand the concept over months. It wasn't fun, but it is fun now. You know what? These months have been worth it. I really am not kidding. Months ago, when Flame first joined on the live stream, I was just beginning my whole chemical journey, and back then I genuinely had no idea what chemistry was about. I was learning like really basic stuff, what protons and neutrons do in an atom, what the ions and bonding. I didn't even know what the difference was between ionic and covalent and metallic. I knew nothing, absolutely nothing. Now I finally feel confident with theoretical to go into inorganic. Because I feel like knowing theoretical, I'm not an expert, far from it, because it's theoretical. I know very little, but I feel like it will still help with inorganic. It's been 2 hours, wow. 2 solid hours of just learning spin. My MAKiT in the corner just gave up. And it's not, there we go, we're back. Oh, wait, Atomic, you didn't mention the MAKiT. I'm sorry, I got distracted with chemistry. What was the MAKiT you mentioned? Make? Oh wait, you mentioned the toy maker, didn't you? I remember now. Make it toys. Make it toy. Fine, but I'm gonna take creative control on this. Because I have... Make it toy? What does make it toy... What does make it toy even look like? What does make it toy even look like? Plastic? You could do a plastic, make it.
You should go to sleep.
Either atomic. I am going to, but first there's a make it to be made.
That's your bedtime.
I cannot. I need to go to sleep really tired tonight.
What is this? You don't have a sleep schedule. You don't have a stream schedule. What are you doing? What's up?
I'm that one unemployed guy. Just, you know, in the friend
The
group.
one unemployed friend.
Yeah, the
who
one unemployed
lives
friend.
in his basement.
Exactly. Well, actually, no, not mine. I'm just still, you know. Funny enough, most people don't lock their basements. Just you can just hop in.
Oh, nice.
Yeah,
I'll
that's
be
a
sure to do that when I next see my friend's basement open.
that's a life hack. What camera is the one I'm looking for? No, that's not it.
All right, I just wanted to say go to sleep. Go to sleep.
If I have a toy, make it to make.
You should sleep.
I have a toy make it to make. Listen, you said you're gonna make a toy make it, so I'm making a toy make it. By gosh, golly, I'm gonna copy this and we're gonna make it toy make it. There we go, paste it in. Camera is this? I have no clue. There you are. Alright.
I feel like I was losing brain cells while listening.
I mean, this is really
Oh my
advanced
God.
chemistry. Like, insanely
Dude,
advanced chemistry.
I don't even know calculus. I'm watching Khan Academy to keep up with your videos.
I mean, this is on completely other side of the spectrum. So, you know, calculus, that's for math. This was like, well, just really advanced theoretical chemistry. So, I don't think there's anyone other than some real theoretical chemistry enthusiasts out there who would be good at both chemistry, what we talk about today, and calculus. That's a lot.
My man's the duality of man.
The duality
The
of man.
dichotomy. Huh, I didn't know MAKiT was that small in real life.
I am.
On stream you look a lot bigger.
Listen, okay, I'm only 6'5", alright? I'm not that big.
Only
I'm only
6'5".
6'5".
I'm Giga Chad, so I'm always at least an inch taller than you.
Okay, but yeah, but like I have a GigaChat Make It picture on my desk, so you know.
Well, I have sunglasses.
Oh damn it, that's an. Oh no, I've just been owned with facts and logic. There we go.
Fun thing, I didn't actually make this. I didn't Photoshop this. I just saw it on a YouTube video, and I was like, oh, that's cool.
I just took it. Why not?
Yeah,
Honestly.
I commandeered it. I'm in the military. I can do that. I can commandeer things.
It's not a United States property. Do you read books,
It's now owned
Make
by
It?
the government.
Do you read books, Make It? No, I'm not a nerd. I read library text books. They're free. I'm just that kind of dirty commie.
Dude, yeah, LibreText is goated.
It is
I
great.
looked into it. Ooh, I got some good stuff.
It's amazing.
You know what else is goated is the PubMed. You just find medical stuff on there if you like, you know.
Oh, I know. Ali
chemistry.
told me about this before. This medicine stuff. Also, LibreText has medicine books. Also, I have 3 separate copies of Grey's Anatomy on my laptop.
Oh my god! Why?
As a light read, you know.
Oh no, that's just fanfics. Ew. It's just fanfic the show.
Grey's Anatomy. That's the anatomy text with the. I don't know if you're joshing with me or.
No. I am. I don't know.
My profile picture was made in JS Paint. Funny enough, my profile picture was made by a professional designer. And it was for free, and it was on the house. Because I worked for them.
Nice.
Yeah. Am I
What
supposed
did you do for him?
Just the usual, just animations.
Oh, so you started as an animator. I knew
Yeah.
it. I knew you wouldn't know math that well otherwise.
Only
Animators
animators know math.
Yeah.
Actually, every mathematician ever has been an animator. Which material am I? Why am I so bad at naming stuff? There we go. I know what a toy make it would. I need some inspiration. What are some?
Just
Toy.
look up your name in Google.
Make it. What would it make it look like?
And go to images. That's how I found it.
Okay, so it's like color wood that would work, I think. Wood with different colors. I don't know if that will work. That's just what I'm going with. It's gonna be the most beautiful make it you will ever see. It's going to
I'm gonna
be.
hold you to it.
Oh,
If
you'll
it's
see it.
not,
Oh, you're
then
gonna.
I'm gonna take my money back.
You're gonna.
We'll no
You
longer have funding.
take back the $150 at this point.
Now people are asking about the stream schedule. I've planted the idea in the minds of the viewers.
I would just like to mention that if I had streamed an hour earlier, then this wouldn't have been a new day. That's how consistent I am.
Oh my god.
Not even close.
How consistent of little sleep you get? Yeah, I see that.
I don't get little sleep. I may sometimes listen. The thing is, I may
sleep during the day. Got it.
I actually have a rolling sleep schedule. That's because I don't like. You know that awkward time when you're trying to fall asleep, but you can't fall asleep, so you just start thinking about your life, and then you're like, whoa, I don't want that. So, and then I normally just get up and go back to work.
See, I drink too much whiskey to.
Yeah, the thing is, I also
take
thought about
up.
alcohol, but I don't drink. I thought about alcohol, honestly. I even bought some, but
I actually, anyone who knows me knows I'm 20, and I'm currently in the United States. So, if you know me, I'm not drinking. When I get back to
yeah,
Japan,
Atomic
I am
meant
drinking.
in Japan, obviously. In Japan, you meant in Japan,
Yeah,
obviously.
only in Japan. Only in
Exactly.
Japan. And whenever the bartender can't read my ID correctly because I'm from Texas and I'm in California.
Try prescribed or illegal drugs. Ah, yes, the best advice. Try illegal
Yes,
drugs
one of
is such a
the
killer
finest
advice.
amphetamines.
Fentanyl. I love it when I just die.
Oh yes, Xanax.
I don't actually get where drugs are wild because it's actually there isn't like a clear line. Like, you know, stuff like amphetamines to rat poison, it's a spectrum. You could call rat poison a drug. Like, technically it would be.
It's on the same spectrum too. What I don't understand about drugs, I get that they're addictive, which I mean I guess invalidates my whole point. But if they're addictive and you know they're bad, just don't do them.
Yeah, but the thing is, the problem is...
You don't know if it could be spiked or something.
Yeah,
or
but I mean,
laced.
that is obviously true. However, it's a bit more complicated than that. You see, with war on drugs, the thing is,
I know.
there are a lot of, like, okay, weed, for example.
Here we go, politics.
Politics, yeah. Oh, I mean, Stetsos Pretzels did literally ask what is the Americans' thoughts on upcoming election. So, you know, it's much better to talk about the war on drugs than this, in my opinion. I would rather talk about drugs than the upcoming election.
That's a off live Discord call.
The thing with drugs is that the problem, at least in America, war on drugs, obviously, drugs are criminalized to the point where if you are an addict, then you're basically dead, as good as dead. You can't really get help.
If you try Fent, you're dead.
Yeah, but being an addict is illegal. So the thing is, I guess that's a fair point, you know. If you know drugs are this bad, then you shouldn't try them. But at the same time, in my opinion, even if someone tries them, that mistake shouldn't ruin their lives. Like, I get
Right.
it's a dumb mistake to make, but death? That seems a bit rough. I obviously don't mean, death sentence. I mean the fact that, the whole society won't help you because being an addict is basically criminalized.
See, but I also got a book right here by Charles Darwin called "The Origin of Species."
Yeah, but okay, but you could also make another argument, like, what about people who live in cheap areas? So,
Yeah.
with asbestos, for example. Like, it's a similar thing.
Asbestos is so bad.
Yeah, but you.
They put it in our walls on the ship.
Whoa! Oh, whoa! Why? Hold on.
I've had direct contact to asbestos. It's yeah.
Okay, but that's actually a good analogy. So right here, basically, you have your reasons for being in the military, right?
Yeah.
But you're not really forced. You're not completely forced to be in the military. Well, at this point,
No,
you
it's completely voluntary.
yeah, it is voluntary. So like you have voluntary exposure to asbestos. So imagine if the culture around cancer, for example, was the same as around addiction. We're like,
Yeah,
if
let's
you
make it happen.
yeah, let's make it happen, exactly. Well, like, if you get cancer right now, then people would just blame you for choosing to go to the military and spending your time around asbestos.
So it's not always by choice; it's just by circumstance.
Yeah, so for example, a lot of people, through depression and just all, awful things happening in their lives, they resort to drugs because, they're feeling absolutely awful. They don't want to feel this way. And you could argue that's a stupid mistake, but people in a lot of pain tend to do stupid stuff. That's why painkillers, because painkillers are not great for you, but
Dude, painkillers feel great.
but yeah, exactly, but they feel great. Actually, fentanyl is so awful. I really
Fentanyl is 50 times stronger than opium.
yeah. The thing is, fentanyl is just like maximized painkiller. It's the most killer of all painkillers.
I've heard it's such a wild experience that whenever you come back from that trip, you're completely desensitized to the point where even your clothes can feel like painful.
Yeah, the thing is, I get why someone would do most drugs, but for fentanyl, it's well, I still get it, but there are a lot
It's
less
a
reasons.
gamble.
It is insanely. I feel like it's for people who are in pain and overestimate or underestimate rather the strength of it.
Mm-hmm.
But still, even if people take fentanyl, they shouldn't die for it. It is the thing is when it comes to the criminal system, it is an unfortunate truth that punishment is only comfortable but not really good for the society. The reform is what's good for the society, and no matter how irredeemable you may think someone is, most people aren't actually irredeemable. It's better for the victims. So the thing is, victims of crimes feel much better when the criminal is reformed than when the criminal is punished. Because when the criminal is reformed, that means they had to face their awful crimes, and them facing these crimes usually means they have to actually understand just how awful, just how horrible the act they've committed was. That's why, for example, with death penalty, it's really often the victims of a crime that someone committed. When that person gets the death penalty, then that actually doesn't actually help the victims, because that's an easy way out for that person. They just die, and that's it. It's over. And
you just summed up the Lorax when they put the jet thing on his head, on Mr. O'Hare's head.
Yes,
Politics,
Lorax.
the justice system all comes back to the Lorax.
It's always come back to the Lorax. It always come back to the Lorax. Yeah, that's true. Just read the Constitution. It's all about the Lorax.
It really is. All right, well, I just wanted to tell you to go to bed.
Yeah,
I'm
I'm thinking about how to make it
Make
work.
meth. You're gonna say meth.
Hello everyone, welcome to another meth making live stream today.
Chemistry channel.
You actually said, for some reason in my mind, you sounded really similar to Breaking Bad, Mr. White. With what and just
Wait, somebody's knocking on my door, and I don't have pants on. Hold on.
I am the danger. Speaking of. Actually, I would rather the former tax dollars are paying for this guy's prison's meal. So you would rather have him killed?
All right. Yeah. No one's there. It's official. I have schizophrenia.
I actually had that too, or maybe it was the chair, I don't know.
No, it wasn't my chair. I know when my chair is, being a piece of
Yeah,
garbage.
I just don't know if I had your chair or if we both had knocking, in which case that's...
Oh, yeah.
That's,
Oh, my God. Oh, that's real.
that's how most horror stories sound. Alright, remove this, pop this in, there we go. It's gonna be beautiful wooden MAKiT.
Yo, I'm actually about to die.
Why? What's happening?
Yo, you hear that? Somebody's trying to get into my room in the hotel.
That sounds like... Oh no, that doesn't... You good?
No, I looked through. No, dude, I'm fine. But no, he's still there though. But I looked through the peephole, and all I saw was somebody looking back at me.
What the heck?
They're
Yeah,
trying to open my door. Yeah, welcome to America.
yeah, but
I think it's because it's
okay.
like almost Halloween.
At the same
I don't
time,
know 'em, and I'm not that hungry right now. So
at the same time,
I
you
have
live
no
in
reason to
America.
leave.
Would you happen to have a gun, maybe, or?
Being in the military, I don't have a gun. Yeah, the irony, I know, right? Also, fun fact, Stetzel's Pretzels. I'm not getting prison meals. I'm actually getting below quality.
Oh, I think he was talking
prison
about some
meals.
guy who actually killed someone. Don't worry.
Oh. Well, that's a little fun fact about military meals is that they are so bad and that they're not on the boxes themselves it says not suitable for prisoner consumption. I'm dead serious because I've seen the boxes.
I was about to say that fun fact about the military. Actually, they can ignore both the federal. Well, obviously they can ignore the federal guidelines, like health and
yeah.
safety, but they can also ignore the state guidelines because the military bases aren't really part of any state, so they can basically ignore all of them. But that's completely
They're
got
guidelines,
beaten.
They're not rules.
But that kind of completely got beaten by the fact that it literally says not fit for prisoner consumption.
Yeah.
I mean, the audacity to have that in the box, to be fair. I kind of respect it at this point.
Well, yeah, they gotta let us know how much they care about us. The new MAKiT model.
I don't know.
Starting to look like annoying orange.
Yeah, I don't know where to go with this. I don't know what, because the toy thing is, how am I supposed to make it? Toy MAKiT.
Goku.
Hi there, Helena, by the way. Welcome. You've just missed the past 2 hours where we were talking about electron spin. It was thrilling. It was captivating, truly.
Yeah, now I'm here to bring down the IQ, the average IQ in the room.
Exactly. We're here to talk about politics, and it's only serious politics. You see, I believe I should have all the money. That's my personal belief. I feel like that would be great for society.
But I believe that if you had all the money, then I wouldn't have money.
Yeah, but like, have you considered the benefit of me having all the money?
I haven't. That's a good point.
Yeah.
No need to elaborate. you get all the money.
I have all the money now. Okay, how do I...
Okay, so I have to know, how long have you been animating? Because clearly it's at least a day.
Maybe even 2. Think about this. I don't know.
You had a job
Yeah.
prior as an animator?
I still have it.
Was
I
that...
still do.
Oh.
It's not prior. It's just not... well, it's freelance. Yeah. The thing
That's
is...
how you pay the bills.
Yeah, actually it is. That's why you don't need to keep sending me money for it. Well, you're sending it to charity now. I'm glad, actually.
Yeah, no, you put a wall there.
No,
Now I gotta pay a grand in order to start paying you again.
yeah. Now, actually, now she's gonna be extremely. It's pretty awful of you to donate to me now because well, it's a fundraiser. It's supposed to donate to charity. I actually feel like I should donate around $100 to this fundraiser because I'm pretty certain that the
square up to my number.
no, it's because I'm pretty certain the money from the ad revenue isn't going to the charity. I actually don't know if it's going or not, which is already bad enough. The YouTube's tool for fundraising for charity is so awful, so bloody awful.
I can imagine everything from YouTube's awful.
No, YouTube is amazing. We love YouTube. YouTube, oh, we love you so much. Oh,
you're never gonna get sponsored by YouTube.
I don't care. My most recent video is getting a lot of views, so you know what? A lot of impressions. I don't care. Oh, YouTube, my beloved.
Yeah.
Oh, if I had a nickel,
Got a lot of views.
if I had a nickel for every single time I was like, oh, YouTube is amazing, then I wouldn't even need to be
You'd
monetized.
have at least a nickel.
I'm just gonna donate $700 to charity on day 700. I don't know if I can afford that, honestly, at this point. I'm trying to transition from my freelance job to the YouTube job. The thing that's
Is
why
it making you?
kind of I am making myself. The thing is, I've just been accepting less things freelance wise because my YouTube is taking off. The issue is when you're freelancing, a big part of it is finding the things to do. And so when you stop accepting them, then people just stop giving you any. Or, you know, start rather looking for other freelancers. And so it's kind of accelerating instead of just, I don't really have full control over it, is what I'm basically trying to say. That's what I'm kind of trying.
Mom, I'm not an alcoholic. I just drink whenever I feel sad.
I'm not addicted. I can stop anytime I want, okay? I could stop streaming anytime I want. I've just been streaming for the past 635 days because I wanted to, alright? That's why.
Yeah, when is that number gonna reach 0 again?
What do you mean? Just try to check up for a reason. Where can I find why? In the fundraiser, that's linked right here. Just
You see the button
on
that says
stream.
Cancer bad. Let's make it happen.
Exactly.
The donate button.
I don't know what the toy MAKiT would look like, honestly.
I don't either. I just kind of said it as a joke.
Listen, I never joke. I'm always serious.
I can't tell if you're being facetious or.
No, I've never joked in my entire life.
Still can't believe somebody just tried to break into my room, and then I sat back down and started talking to you.
Yeah, just casually, not even nervous or anything. Just, you know.
That's how much the military desensitized me. It's just like, yeah, this guy's got a gun pointed at me. So
Oh
what?
no, someone's gonna break in. Ah, sucks. Oh, what if I'll get hurt and I won't be able to go back to? Oh, that would be.
I wouldn't get to go back and eat my burger.
Oh no, that sucks.
I think I would be more upset that, like, that I couldn't have my burger for tonight. Than stabbed.
A true fearless American.
Like right in the liver. I'm just like bleeding out, and I'm like, God, I could have had a really good burger by now, but now I'm in the hospital eating hospital food.
I've actually been there before when I was making sulfuric acid. There was one point when I was electrolyzing heated sulfuric acid, and I remember one time. Well, it happened two separate occasions. The other time I was a bit more careful because I was doing something a bit more dangerous. But once it was just basically emitting fumes, which I weren't expecting, and
Oh no.
it was either oxygen, which will be fine, or it was sulfur trioxide, which would be
my
basically as Harry, the YouTuber who helped me with the project, as Harry put it, would be a very painful way to die. And
Oh my
when I realized that it's
Same.
emitting, goodness no, I'm not a chemist.
Oh my
I
god.
can barely afford like a hot
Bro's
plate
the
and talk about.
backyard chemist.
Yeah, the thing is,
And today we're gonna be drinking sulfuric acid.
the thing is, when I realized that it's either emitting oxygen or sulfur trioxide, the reason why I was so upset that I would be emitting sulfur trioxide wasn't because I would die a painful death, only because then it would just go back to being water, not sulfuric acid. That was my first thought, like, oh damn it, all of this work for nothing.
Damn.
And then another time I was boiling sulfuric acid, but I was boiling it overnight because it was taking such a long time. And when I came back, it was basically it went like 30 millimeters further than I was expecting it to, which is a problem because I was expecting like 50 millimeters and I got 20. That's how long it's been boiling. And the fumes were just so unbelievably thick. It's,
Oh my gosh.
yeah, the thing
What
is,
do they taste like?
oh, I didn't even, I wasn't breathing at the time. I was just going in, holding my breath because I knew that breath could have been my last one. That because when for the first time
Not
when I
even a
was
good breath.
when I was electrolyzing it, I wasn't sure if it was oxygen or sulfur trioxide. When it was boiling, I knew for a fact it was just a lungful of deadly,
Straight
smelly
cancer.
stuff. I don't know if it would be cancer or I think it would just shred my lungs. Actually, I'm pretty
In 20
certain.
years.
I'm pretty certain I would just. I think I would suffocate my own blood actually, or it would destroy
God.
my throat. I don't know what first.
Oh gosh.
Well, good night, lovely people. Good night, Helena. I'm so glad I just.
Somebody going to sleep.
Helena joined in at a pretty awkward time, to be fair. Just
Yeah,
from
listening
us
to-
talking about politics to us being like, hey, yeah, so I was someone is trying to break in. Yeah, that's basically almost shredded my lungs.
No, but it do be like that sometimes. You just gotta get work done. And you don't really care about the consequences. Like we have to pull fuses on the ship, and mind you, we're up we're generating upwards of like 400 volts, which
Actually,
for
it's-
those who don't know, if you get shocked by 400 volts, it wouldn't be the shock that kills you, but your body splattering on the back wall that kills you.
Yeah,
because
400.
of
That's
the sheer
actually.
force of it.
Yeah, the thing is,
of
what
it
matters
shooting.
here is, if I'm not mistaken, it's not actually the volts, it's the volts and amperage. So, volts is basically
It's
like.
at like if I'm not mistaken, like 240 hertz. Yeah.
Yeah, if. I mean, the thing is, I'm assuming it's a lot of amperes because, well, it's a fuse on a
It's a
ship.
lot, yeah.
It's obviously gonna be a lot. But the
Yeah.
thing is,
A warship.
yeah, the thing is, when you could just get shocked with a lot of volts, it actually doesn't have to do anything. You could get shocked with millions of volts and you could just be just fine. Because
Sure, but
volts is
there's
basically.
no ground on a ship.
No, the thing is, the reason why it's so dangerous with a fuse is because normally when you have so many volts, volts basically tell you how, to oversimplify, how hard electrons are pushing in. Amperes tells you how many electrons are
This is
flooding
too
in.
much.
So if you have 400 volts with like 1 nanoampere, it's gonna be fine. However, if it's a fuse, you're not gonna have 1 nanoampere, you're gonna have like 24 amperes or, well, I don't know how much on the ship. And 24 amperes with 400 volts, that's, to say that's deadly, it's an understatement.
I think they are. If I'm not mistaken, it's like
Yeah,
24 or
that's
12.
actually 12 also seems reasonable. So even 12, that's 12 times 400 watts. So that's 4 kilowatts, which let's just say is
Yeah,
not
that
little.
sounds about right. Yeah, but like we were more. I was more worried about breaking the fuse and having to get a new one than I was just getting shot back into the bulkhead. And like they show us the images of some of the aftermaths of those incidences, and oh, they're bad.
Oh,
'Cause you're working on a on a
Imagine.
ship on water where there's no ground. You are the ground.
You are the ground. I actually don't know how it would work on a how electricity would work on a ship. I just realized.
I can describe it. I can describe exactly second by second. 1 second you get shocked. The next second you have a hole in your foot.
The thing is, I don't know, military is wild. Never been to. Never plan on going.
The land without regulation.
No, you are the
Filled with
regulation.
rules.
Still, a meal not fit for prisoner consumption is kind of funny.
Fact. Yeah.
Well, probably not for you, but
Yeah, no, I don't care what I eat as long as I get bread. Also, sometimes we run out of bread.
it's gonna be, yeah, it's, you know, in the military it's gonna be like, it's bread, and then an asterisk. Technically should not be called bread, not to be confused with bread, like, legally distinct from bread.
Not to be confused with cornstarch.
Yeah, have some sugar, not to be confused with sucrose or glucose, or, and then just list
Oh
every
my
single
god,
kind.
the sugar cookies. Ugh. Ugh. Sometimes they come out like actual bricks, and sometimes they're like the best thing that's ever been made. And sometimes they're the best thing that's ever been made, and they sat out for like an hour and a half. And so they become bricks. The default is brick. Just like how everything deteriorates to lead. On the ship, everything deteriorates to bricks.
Actually, wait, hold on. What do you do when you're on the ship? Actually, like, I can't just imagine it's.
Nothing.
I mean, I can't just imagine
so boring.
you're just, you know, like, just sailing with a ship just for the, I don't know, just to show that it still works or something. Unless that is why you're going.
Like the purpose?
Yes.
That's a philosophical question that I can't answer, and the next 3 admirals above me don't want to answer.
This is.
But what you do on a ship, it really comes down to your work schedule.
Oh,
Depending
I
on your
actually have some
Yeah.
history with sailing, so I kind of get that
dude,
one.
So I've heard.
You've
So
heard?
I've heard. Yeah, there's another person on this server whose name I've forgotten.
Yes.
Met you in person before. Met
Did
you
they say that
sailing
really?
Before, yeah.
That's possible.
But you went to bed and didn't want to stay up later.
Yeah.
On our Discord call, so you didn't get to hear that lore.
Or the deep MAKiT lore. My deep tragic
MAKiT
backstory.
Man, I fell off my boat. It was so bad. I saw nothing but blue for 7 days.
I was bitten by a radioactive scientist.
Whoa. Whoa, you gotta chill with that. Somebody already in chat has their like scratch board up and they're like, yes, ideas. I'm gonna draw this. Next thing you know,
I
your
wish.
server's gonna be
Listen,
filled with it.
if someone is gonna listen, I'm all for it. If someone wants to make like smut of me, I'm gonna review it. I'm gonna give my honest feedback.
If anyone's gonna do it, it's gonna be me.
God,
I've already seen some of my art.
you want go for it. Listen, as I mentioned, I'm gonna make a video.
I draw females better.
Fair point. Whoa. Hold on now. Practice.
It's
Practice
easier
makes
for me to-
perfect.
Yeah, a lot of practice. Too much practice.
Make it smart, please. That's what I'm saying, Bennett. You can't just ask me.
Let's
We're in
make
this
it happen.
pun intended. Listen, pun very much intended, but we're in the same boat here.
Oh no! Oh, I can't tell you how many times I've made that joke and just gotten nothing but hatred out. It's like, come on, guys. There's no need to be angry. We're all in the same
I can
boat
just
here.
imagine you saying it like 7 times a day for an entire year non-stop.
Oh my god. Now, luckily, I didn't get put on the COVID cruise, which was like 360 something days with like no port visits.
Oh,
Just pure awful. Because you can imagine, like, all
I
you're
can
doing on a
imagine.
ship is you're working an 8-hour shift, and then you're standing an 8-hour watch, and then you're working a little bit more and hoping that you get 8 hours of sleep. Yeah. So and depending on your watch times, if you get the watch time during the working day, then you work a lot less. You see how that works?
Mm-hmm. I see how that works.
Because you don't work. You just sit there and stare at a computer and wonder why you enlisted. Sadness.
No, I just did not feel for prisoners. Kind of still cracks me up.
It's true.
Actually, does the Geneva Convention apply to the like enemies, or does it also apply to? Because that's actually a very
It applies to
convenient loophole.
Everyone.
Yeah, so you can't.
Mr. Beast joked that broke the Geneva Convention. It was funny because they were doing the like the prison challenge or whatever. This dude stays in a room with no windows and whatever, and
That breaks
they
the
weren't giving him sleeping time, which is it's a war crime. You have to
Hey.
give even prisoners.
Listen, I know it's a war crime and all, but think of the viewers. Listen, I do a
They
war
actually
crime
scrapped
before.
that video.
Ah, that's a shame. Why? It's just a
Because
war
the guy
crime.
doing it had a mental breakdown. It
God,
posted on the
I can.
allegations. The Mr. Beast situation goes
Oh,
crazy.
you mean to tell me that if you do a war crime on someone, they might have a mental breakdown? I
No.
am shocked.
No, don't try it.
I feel like we need to test it ourselves. We need a
If
volunteer.
anyone's gonna do it, it's gonna be me. I'm gonna be locked in a room without nighttime hours for a month straight and getting absolutely nothing in return except for PTSD and hatred for the world.
That's how you man up, so we get real manly. With no sleep, with or maybe crazy, or was it crazy or manly? I don't know, close enough. Yes.
All right, I've got a burger to go eat.
That's reasonable.
make
Don't
like
let
a
anyone kill you on the way there,
potato
by the
chip.
way.
I'm actually worried. If not, I'll just crawl out my window and hope they don't meet me on the other side.
Yeah, just like text
on the
in the
third floor.
Patreon. The cloud can't be fine. you're what? You're like 6'8". You'll be fine. You can just walk down there.
Yeah, I'm exactly 13 feet tall.
Yes, perfect. Just specifically for these situations.
Solid,
Yeah, just
solid muscle.
Text me in the
1,372 pounds.
just text me in the Patreon channel later on if you're still alive, because
If I'm dead, I'll let you know if I'm dead.
Yeah, that'd be nice. Just let me know if you're dead.
Say anything, if I don't,
That means
say
you're alive,
anything
yes.
In like 2 hours,
That means you're
then
alive.
I'm dead.
Ah, that's confusing. Just text me when you're dead. That'll be so much easier.
Okay. Yeah, I just won't say anything at all for the next month. You can assume that I'm alive.
Oh, just like my childhood friend swimming in the pool. He's extremely good at holding his breath, I gotta say. 7 hours? That's
I'm
impressive.
So bad at holding. Oh God.
Anyhow, I'm gonna be going to. I am tired, believe it or not.
You go to sleep.
Yeah.
That's the whole reason I joined.
Believe it or
Mission
not,
complete.
I'm actually tired after the whole
I
live
didn't know
stream.
God sleep. Whoa.
Oh no, I'm just, I just need to go into slumber, let mortals do their thing.
Oh yeah, that's right.
Mortals, mortals got a mortal, am I right?
You've got grapes to eat.
Yeah, right. Grapes to eat, animals to turn into, women to impregnate.
Yeah.
Greek law was
Oh my
fucking wild,
God.
honestly. Just Zeus going around absolutely not holding it back in any way, shape, or form. Literally,
you know
shape or
what?
form.
You gotta watch this new show on Netflix. That I don't actually know what it's called right now because I haven't watched it in like a month, but I'm pulling up Netflix right now.
What's it about?
It goes over the lore of of these Greek gods, and it's just so gruesome.
Is it like an animation?
Yeah, it
Oh, I think
is.
I've seen somewhere.
I have the Twilight of the Gods. Yeah, that one.
Alright.
It's so good. It's like a Dungeons and Dragons campaign, uh, except they're trying to kill gods. All right, we'll go to sleep.
Yeah, I'm going. Alright. Well, bye then. See ya.
All right, bye bye.
And see you all tomorrow, because I stream every day, of course. It's great. Anyhow, for now, I suppose that'll be it. Thank you everyone so much for watching, and have a great day. Bye.